do, do, do. Here we go as the software is starting up. Make sure I have everything in order here for you guys. Squeezer, screwdriver, solder, hot air station, scope. Hello, hello. Hello once again today. Just a few minutes early here as I get everything set up. Ali, hello, hello, thanks for joining in. I can't remember what I had down for the title of this one, but I'm gonna see if anyone can guess what is wrong with this. This is an MD12K, so a Taramps MD12K. So for any of the people that do repair Taramps, they may have a good idea of what is wrong with this board. Hey, DJ Bell. Hey, thanks for checking in. Check, check. Yes, yes. Check, check. 1, 2, 3. Mic's on. Cameras are running. So I had a live stream earlier this morning, and then of course, you know, the other part of business is when you finish an amp, you got to get it all put back together. So I didn't want to bore everyone with reassembling that other amplifier today, that Class AV that I did earlier. Hey, Jesse. Hello again. Yes. I had to take care of some assembly of some amplifiers and get things lined up for load testing. That's why I had a little bit of a break in between the live streams today. And as I mentioned earlier, I did have a Taramps MD12K that I wanted to do on a live stream for you guys today. So I know I'm a minute or two early. But, you know, these Taramps, they have common failures. And that's what I wanted to go over today. Was just the, not really go over the common failures and I don't want to scare anyone away from Taramps. They're great amplifiers. They are powerhouses for their footprint. They're a ton of power for their size. But they do run their equipment really close on their voltages, and there are a few things that I personally would do a little different on these boards. Probably, you know, from the build house, I would do things just a little different. But otherwise, these amps, they're just powerhouses. If you have the right system and electrical setup, you can run these things all day long. As long as you understand this is a Brazilian style board and not a Korean style board. So some of the common failures of the MD line, especially the 12Ks, are one of the biggest ones are burnt traces. Again, it goes back to just the massive amount of current that goes through these. I think I've mentioned this before on other videos that there's just a ton of current that has to go through these traces. Now, this board doesn't have that burnt trace failure. Usually you'll see those failures on the drains of the transistors here. They'll burn the trace right at the board on the top side, and sometimes you'll get some burnt traces on the bottom side. So that's one of the more common failures of these MD12Ks. But there's another failure of these 12Ks that I do see quite often, which you really can't tell from the top of the board. So I'll get throughout my email correspondences with customers, I'll ask them to, you know, take a picture, take a look, or if they're willing to take the cover off, and they'll say, oh, nothing looks burnt. Well, I guarantee you there's something burnt on this. And I think it all goes back to how these boards are flowed, when the flow process, the assembly line. I think they really could save a lot of headache on warranty repairs if they were to just do a little bit more QA/QC on their boards before they send them out or put them in heat sinks. But this is what you're going to find. Typical, I should say the second most typical failure of an MD12K is, as you can see, the inductor. I don't know if it's just a lack of solder, a lack of surface area. Anytime I submit my warranty repair work, I do mention when I have a failed inductor like this that I do believe it's from a lack of surface area or a lack of solder joining the surfaces. So hope someone, you know, there at Taramps listens to my little notes when I submit my warranty repairs. But yeah, that's what we have here. The typical common inductor failure, which they're not too bad to repair. I've done several of them. They make more of a mess than anything. And believe it or not, 9 times out of 10, the output section survives due to vibration. I have seen some inductors come apart here at the traces from vibration. Now, this inductor in particular, it was, they did have it silicone down pretty decent. So I don't know if I can say it was a vibration failure because there's no signs of that on the other inductor. I really don't know. Of course, you know, one of the biggest components of amplifier failure is vibration. But again, I'm just not seeing that on this particular instance here. It could be, though. Highly, highly probable that it could be from vibration damage, just breaking the solder joint around the inductor. But again, usually there's other signs that there's vibration damage. A lot of times, I'll show you guys real quick, when I see some vibration damage on these amplifiers, do I have even shot here? Yes. These resistors right here, these 10 ohm, these 5 watt resistors, they'll break right off at the legs because there's nothing holding this resistor down. So usually when I see a vibration issue, I will see it at these resistors, which I don't see that here. That's another one of the things that I look for, because what's one of the things that's not covered for warranty repair, that would be vibration damage. They do state that the amplifiers have to be securely mounted, which I'm sure that doesn't mean securely mounted to your speaker enclosure, but mounted in a way that does not introduce vibration damage. And you can see all the little skid marks that were left by the exploding trace here. I'm just going to clean up. Oh, and another thing, I just wanted to quickly get on video, if I'm going the right way here. One thing I wanted to get on video, on record. Oh yeah, any day, Jesse, any day. I get a lot of questions about these two resistors right here. I'll always get a question, what's the value? So I just wanted to get it on record, on a video, that maybe if I one day manage to put videos in groups, that these resistors here at the RCA inputs, they are 10K each. if they're in parallel right now. So if you're to read across them with a multimeter, you will see 5K here. I think these might be fusible resistors. So just to let you know on that also, they're small. I think those are 1/4 watt resistors, or they're 1/8 watt fusibles. You could probably get away with 8 watt metal films that'll open just as quick as a fusible resistor, but that's what those are. Those are 10K resistors. So what we're going to do is we're going to heat up the desoldering gun here, and we are going to remove the inductor. This is how I go about repairing pretty much all these failed inductor situations. I'll remove the inductor, and we're going to repair the trace. We're going to save it the best we can. So I'm going to add a little bit of regular normal leaded solder. Pick up that nasty lead-free stuff, the stuff that we just love. You know, you all love that lead-free solder. And then if you just lightly take a pair of side cutters, you can kind of pop that leg free off the board here. So it's free, and it's free. And I could probably, once you do enough of these, you can do these pretty quick, easy repairs. So what I want to look for is make sure that the winding itself has not wore through anywhere where it wasn't supposed to wear through. I've had some inductors that'll rub the center. Here, the very first coil will rub right into the board and it'll short out right on the board right here. And I do have a solution for that also that I will do before gluing these back in place. I see kind of an odd mark on the top trace here, which is kind of hard to see on camera, but let me see what we got going on. Oh, it was just the current trying to find its way. It did a pretty good job at taking out this trace here. But never fear, there are ways to fix this. I may have to flip it around though. Get the inductor on my side. All right. Oh, not too bad at all. And I had already gone through and measured. I don't have any shorts on the output transistors on either side. So you got what, 6.7K to 8K. I can't remember exactly the range on that. Again, resistance mode. I know my favorite thing to use is resistance, but I'm not showing any shorts there. And again, a lot of times on these inductor failures, I don't see those shorts. So sorry for the fingernails on the chalkboard sound, but what I'm doing is I'm just scraping away the solder mask around where the inductor leg goes through. Because we're going to use the remaining part of this trace to solder on some copper braids that they're going to go through the hole and then wrap around the board to get around the leg of the inductor. So that's what I'm doing now, just getting ready. To solder around. The repair's got to be sufficient enough to carry a lot of current. So since the via itself is gone, there are some, let's see, there's 6 punches here. So there's 6 vias that are still good through the other side of the board. So I do believe we're going to have plenty of copper here to attach to redo this. And I just put a little bit of flux on the copper so I don't get any oxidizing films while I'm preparing it. I'll flip it over and see what's left of the bottom side via. Could you add a jumper wire if that pad is not able to take solder? Yes, that's more or less kind of what I'm doing in a roundabout way, is making my own jumpers, but from one side of the board to the other. Now, if you didn't have any of this via left, then you would have to bring your copper. I really don't use wire because it's not very flexible. What I do is I use copper braid. And you'll see here how I do this. Hopefully, if I can get you guys close enough to see this. I'll show you how I go about doing this. Of course, I add my flux. Solder does not like to adhere to copper if there's any oxidation going on, so. And I'm just going to tin it up real quick here and see what I have to work with. That's actually not bad. Let me see. Can we get any closer on that? Excuse me, guys, as I'm going to move the camera in on you here. So you can see I have a little bit of the vias left right here, which is good. And now the hole that it made, we're just going to go ahead and dig that out. We really don't care about the size of that hole. Sometimes if you can make it a little bit bigger, you'll be better off because you got to get some copper braid through there. Hey, Mark. Well, yes. I mean, you will hear a lot of people that don't like the design of these. I'm just a repair tech. I mean, a design is a design. So, now if I was an install person or had the install end of business, I might have a little bit different opinion on that. But I just, you know, it's a design. It's just another design for an amplifier. It does have its ups and downs. It does have some weak points. It does have some strong points. But you know, all around, it's another typical build in my opinion. So there you can see, guys, where I had cleared the solder mask off from the top side. As they appear in series. Well, okay, let me see if I can. So one inductor comes through and goes to one speaker terminal. The other inductor goes through the other speaker terminal. So there, see if I can get this here for you. Yeah, so one inductor will come through to one terminal. Your other inductor comes through and goes to the other terminal. Then, of course, you have your filtering capacitors in between the two. So I don't really, I mean, you could consider the inductors in series once your load is attached. But yeah. And the diameter of the wire, give me 2 seconds. Let me get my caliper here. It's 2.15 millimeters. So it's 2.15 millimeters on the inductor wire. It really is designed to fail. That's, you know, and I mean, that's some, and if they are designed to fail, they keep me in business. The thing is too, they're all even a lot of these Brazilian boards are the kind of the same. They're the same design. So I have a Sound Digital board, a 12K over here that I finished up yesterday. I mean, it's the same design. It uses the SI8244. They're all, again, the same, more or less. Make sure there's no damage on the inductor itself. So the inductor is great. It's just the trace. It needs a little bit of help. Yes, yeah. So you're correct. So Mark, you are correct. It would be passing through both of those. When you look at it from the point of view that once the load is attached. Which, yeah, it's a ton of current. I mean, don't get me wrong. I mean, that's why these things are notorious for blowing their traces. They're a lot of current. It's a lot of current. I have repaired many 12Ks for pretty much the same failures. And again, you know, they're aware of these issues. At least they should be. I mean, I think all us repair guys have mentioned enough about these issues. But again, I just leave it up to the engineers. Let's see here. Hey, Tech. Hello to everyone. How long has this been live? And we haven't missed so far. Oh, yeah, I started this one at 3 o'clock. I was live earlier today too, but I had to get some amplifiers put back together. So once loads attached. Yes, Mark. Mark, do I are you on Facebook, or I recognize your name from somewhere other than this channel, I thought. I haven't repaired an amp for you, have I? Mark has a good point. Wonder what the loss is there and how it's only a 5-foot coil. Yeah, so this uses full banks of the IRFB 4127s. So rail voltage, these are 200 volt rail caps. I think the rail voltage on this is 180 volts, I think. Is the rail voltage on this? Don't quote me on that. I don't like to memorize things, really, because there's a lot of numbers that I have to remember. But I think it's 176 odd volts on the rails. So what I'm doing is I'm just getting my copper here set up. Oh, hey, thanks, Mark. Yeah. So the 2.1 millimeter equals at a 30 amps per meter of current density, literally designed to fail. Yes. Yeah, you know, and if you guys have any suggestions at all when it comes to the designs, you know, I'm sure Taramps, of course, they have their engineers that do things. but I'd be more than happy to, you know, let them know what the consumers are saying. Yeah, no problem at all with letting Taramps know. I just do their warranty work, so let's see here. I'm not. What is the issue with this 12K? Burnt inductor trace. The typical common burnt trace. And I can show you. Let's see if I can get you really close down in here. So if you were to take a look, will it focus? Focus. Focus. The I don't know what it's trying to focus on. Probably this capacitor right here. The trace, the other side here, you can see the via. You can see where they flowed a bunch of solder right here. But look at this gap right here. This little gap, about 1 millimeter here, that gap, that'll burn open one day. I mean, if I reinforce this and you get all that massive current flowing back through this again, this little gap right here, that'll burn open. Without a doubt, I see that burning open also. And I do a lot of work on these before I send them back out to help prevent these failures from happening in the future. I do a lot of resoldering, a lot of reflowing, a lot of securing on these 12Ks. And before this even goes back to the customer, I will go through and resolder the drains of all the transistors on the output. Just to help prevent failures again. If I can get one more in there, I'll be doing really good. I may have to make that hole a little bit wider. There we go. But yeah, I call this a typical 12K repair, is what I call this. Typical 12K. Now, hopefully, I just didn't get it to a point where I can't get my inductor back in there. There we go. Well, hey, thanks for joining in. I'm doing great. How's it going over there in that end of the world for you? Let's see here, Jesse. Could they simply use thicker traces? Yes, thicker traces and more solder. That's what I think would help these boards. I mean, it's pretty obvious that they flow these boards on the bottom side, and it looks like they do some manual soldering just a little bit on the top. But what they need to do is they need to go through and manually solder in all these drain traces here. And the drain on this section and the source on this side. But you can see there's no solder here. from the flow process, because they don't flow the top, they don't flow the component side, they flow the bottom side. But then I think that goes back to, you know, hours, manpower, or whatever it may be. But yes, more solder would benefit these boards 100%, or thicker traces. Answering your question, I'm following of yours on Facebook, but I am camera shy and social media shy, and I tend to stay in the shadows. Yes, I thought I had recognized your name there, Mark. Thought I did. Yeah, I'm camera shy too. Getting better at it, but at the it was pretty tough at the beginning. So before I slide that inductor back on the board, I am going to add a little bit more solder to the other side, to this side right here. I'm going to bring that solder a little closer to the via, help close that gap up. Now that's what I'd like to see come from the factory. And of course, again, I will go through and resolder the output transistors, but this time we're going to go ahead and get rid of some more of the silicone here first. I am not a fan of silicone to secure stuff on boards. I don't know why they use it. To me, it's still too pliable. It just, sure, if you want to hold something down, but it does nothing, in my opinion, to help prevent anything from vibration damage. It's not solid enough. All right, so I got the bottom surface cleaned up for a reason. I don't know if any of you have watched me before do some inductor repairs on these, but I actually slide an insulator underneath the inductor to keep the inductor from shorting out to the board. The trick is to get the inductor back in. All right, let's see here if I can manage this. As you can see, I got to really kind of wrestle with the board, the inductor. What I'm going to do is I'm going to solder one side back down. Just to hold it in place. There we go. With the god-awful glare of these lights, I do have a lot of lighting, so I'm kind of, I don't want to say I'm blind, but it is kind of dark. And then what I'm going to do is I am going to pull up on the inductor leg here. If I can get it. There it is. And bend it over. Just like that. So as you remember, I have copper braid through the hole. So I'm going to add some solder to the inductor leg itself. And then take my solder braid back up, right up against the inductor leg here. And just like that. Then bend over the other leg and finish up the other side. Let's see here. Okay, so thicker traces answering your question. I agree that there will be a gap, needs more conductive surface area. Yes, yes, indeed. Lots of current needs lots of surface area. More vias, more whatever it takes. That's really, I mean, really all that these high current amplifiers need is just lots of surface area. Just like that, I'm just making sure that my copper on the top side is still good to go. Let's see, you mentioned Facebook. Do you have a business Facebook or is it a personal one? I think it's personal. I'm not sure. I'm really not a I really don't know Facebook all that well. It says my name, so I thought when I set it up, I'd set it up as my business, but it shows my personal name, not my business name. All right. Well, I'm going to bet money I have more surface area on what I did than a single wind of that inductor. But that's neither here nor there. So let me get my silicone set up to go underneath.
What's your name?
That's what I was saying. What's my name? They asked if it was my business or not. So I'm going to take my silicone insulator and I'm going to slide it right underneath. Maybe, or did I get it too tight to the board? No, it should go right underneath. So and that is how I protect the bottom side of the board. Maybe usually I can get these things to slide in pretty easy. This amplifier has been hot too. The thermal paste on this board is pretty dry. There we go. And then it pops out the other end. So I slide that underneath. And then I take my good old, again, my Gorilla Glue clear grip. Great stuff. Now this stuff, when it dries, is a little bit more solid than silicone. So this inductor will not move once this stuff sets up. And I will glue that inductor down because I do not want that inductor to move. And I'm not bashful with this stuff. I will just lay it in there. It's a minor expense compared to, you know, coming back for warranty repair. And then of course these resistors here that I was complaining about earlier that will eventually vibrate off, they do get a little warm, but not so hot that it burns the glue. Now once that sets up, those resistors those will never come off the board. So there's that inductor. Now what I'm going to do is I'm going to flip this board around and I'm going to insulate the bottom side of the other inductor. Which is really tight to the board, so you can get these to slide in enough. There we go. Perfect. Just like that. So now the inductor winding itself won't wear its way through to the trace, because when that happens, it usually blows the inductor wire apart. And then we're going to glue that down in place also. And by doing this, you will really you'll greatly increase, in my opinion, the lifespan of this amplifier. There's some customers that I have where I'll let them know if because they will run just, you know, 5, 6 of these things or whatever they have set up in their competition rigs. I'll let them know, hey, if you really want longevity of the amplifier, send it to me before you start running it so that I can do some, I don't want to call this upgrades, but just some preventive maintenance on the amplifier itself to help prevent future failures. Because again, I've done enough of these where I know what fails on these. All right, now that inductor will go nowhere. So as I had mentioned, you want to resolder the drains and sources of these transistors. So what I do is I just take my soldering iron, and where they have the solder mask removed, I just go through and I will solder those blank areas of the board. And now I will bet money that this will not come in for burnt traces. And the people that, you know, buy these, they don't know this. And then when it fails, they get that bad, you know, I don't want to say taste in their mouth, but they, you know, that's where they get the reputation of failing for no reason. Is because of just simple little things like this that can be done in the in-house before it gets sent out to the customers. Just solder the traces. Hey, hey Damon, how's it going? Good to see you. I didn't know if you were going to be around today or not. I was thinking of you when I was doing my live streams for today. You know, Damon, just doing another Taramps. And this one is not a this one's not a warranty repair. This is private repair. So this is past its date, and the owner has had it for several years, he said. So this one does not fall under warranty repair. This amplifier was punched out in March of 2020. So I'm just going to go through and just reinforce these traces. That way, when I send it back out and I say it's good to go, then that's what I mean. I really do mean it's good to go. It should not have trace failure or any future inductor failures once I am done resoldering all this. You do have to be careful, though, to make sure that when you do this, you don't get any solder bridges going on, because this amplifier does not like solder bridges. You will burn a trace out somewhere if you have a solder bridge. I'm going to flip it over, and I'm just going to go ahead and solder the other inductor, kind of like a reflow, I should say, just to add a little bit more mass to the inductor itself. Yuck, yeah. Now came home and lucky to catch your stream. Hey, thank you. A little late. Oh, you know, the thing with me is I always have an amplifier to repair. Business never stops. Let's see here. I think I'm gonna do a live stream today. I got 3 identical audio pipe 15s that I might do just to show 3 of them at the same time. Oh, fun! Yes. Hey, Damon, are those the newer audio pipes that are using the Brazilian style boards, or is it the Type 4 boards? March 2020, I have a couple of SoundStream Triple X. Oh, yes. Oh. Hey, Mark, yeah, I don't know if you've seen on Facebook, but I did repair a Triple X just not too long ago, and man, I tell you what, those are beasts of an amplifier. Never needed to repair them. Yeah, it's, if you look at the Triple X on how it's designed, the output section of it, you will see why that it has a very low failure rate. They're really a great design. Are they Type 4 boards? Oh yeah, Type 4. Oh yes, Type 4. Yeah, get that. What time are you gonna think about doing that? If you do a live stream, I will be on there for you. Yeah, and Velo has, I think he is working on a Type 4. I'm working with someone on a Type 4 that's having a problem, and I can't remember if it's him or not. Maybe he'll pick up some new information. Now, hopefully my solder joints aren't too tall. to where they're going to catch on the board. I doubt it, because a lot of Taramps here, they have a lot of room because they have such heavy flow soldering on the bottom side. All right, I'm just gonna type for crazy. You most likely watch as well. Yeah, yeah, everyone, we're just gonna have to go catch Damon's live stream. So now, right now, I'm just reflowing the drains of the underside, which they're flowed pretty decent from the factory. Again, because they flow the bath is on the bottom side of the board, but I like to add just a little bit extra because I do get some trace failures on the bottom side. It's not often, but I do. Looks like the rectifiers could use a little TLC here also. And this is what I do just to help prevent future failures. Because, guys that run these big amps, they run them hard or they run them in the dirt, which you really can't do with Brazilian boards. But they run them hard. And if I send an amp out and it fails, I mean, they have a 90-day warranty on it. And if it's a section that I worked on, then guess what I'm doing? I'm going to be repairing it under my own warranty. So I want to make sure these amplifiers are good to go before they go back out. Otherwise, I think we're looking pretty decent. Not seeing any issues that would concern me. Everything's looking trace-wise and solder-wise is looking good. Yeah, I'm just not seeing any other areas. Let's see here. Damon, I have an old school Rockford Fosgate. Yeah, Damon is the Rockford Fosgate guy. I have been working hard to understand the what is that? The T1500 BD style of amplifiers. I'm starting to learn their topology on their output, their feed. I think it's the feedback, or it could be a servo circuit. I'm not quite sure. But Rockford Fosgate's one of those that I just really stay away from. I'll repair them as long as the customer's not in a big hurry to get it back. So I'm just going to go through and make sure that my resistance values are still okay. Would it be worth it, I guess? Would it be worth it? Hey, techno specialist, this is a comment that I made on my live stream earlier this morning. And even for a repair person like me, or even for Damon, when someone asks me if is it worth it, I'll say, well, how much do you like the amplifier? I won't put a worth on someone else's amplifier. I'll let you know when you're approaching the cost of not being economical to repair, but it's your amplifier. You want it fixed? I'll fix it for you. It could be just a big pile of garbage, and I'll fix it for you if you want it fixed. I won't judge what it's worth. So 6.8, 6.8, 6.9, and 6.9. 6.9 and 6.9. So this is one of those amplifiers where the output inductor failed, shorted out drastically, but yet nothing, as in the output transistors, failed. So the output transistors are still good. I have not changed the output transistors at all, so I don't have to worry about DC offset, but I will still check the DC offset when I fire this up. I will do that with every Taramps before it goes back out. Sometimes you'll see that from the factory, you're going to have 0.2 of a volt DC offset from the factory. And you can adjust that. I've been down you know, into the, what would it be, 200 millivolts, 2 millivolts, 0.002. Come on, guys, help me with the decimals here. Let's see here. The replacement boards, the old ones are not repairable. Oh, I know what boards Damon's talking about. Yeah. Hey, Damon, I got a question for you. Since you're here and you're on here, let me pull this out here real quick. Is this the same style of card? If this camera, I don't even know how to make a camera focus. Is this card one of those same style of cards that is not repairable? It's that, I don't know, a ceramic based carbon traced board. These came out of a precision power amplifier. Are those boards repairable? Is that, and you have to use that lead free solder? All right, so let's oh, the gain on this was up about 3/4 of the way. Woo-wee. Oh, and also, guys, on the Taramp boards, I do glue down the RCA jack. What I'll do is I will take the glue and I will put a little bit of glue right on the end of the RCA jack. Because these RCA jacks, I don't want to say they're cheap, but they're kind of cheap. They're the plastic RCA jacks. And sometimes I will get these in and they will be broke right at the board. So if I don't have any shorts, 17K across the speaker leads. Let me check my drain to source, make sure I don't have any shorts across my drain to source. I've done that before where I've went through and reinforced the traces and had a solder bridge on drain to source. And once the full rail voltage built, it kind of went up like a firecracker. And man, is it loud. You can ask the wife that one. So, shall we give it some power? Let's see here. Negative, positive. Oh, I forgot. I burnt up one of my... Darn it. I was working on a B2 that had, and I didn't know at the time, but had a shorted transformer. And when I fired up that amp, it my ground leads going from my power supply back to my scope melted. I didn't know why, but then come to find out I had a short in the transformer sending the secondary side of the transformer out the RCA jack. Yeah, okay. Let's see here. I do not use hot air gun on aluminum caps. Oh, yeah. Hey Todd, well, you'll have my MD12K soon at that and that Stetson. Oh, hey, SS Steve, hey. Oh yeah, we spoke. I remember. Yes, that Stetson amp. Was that the Draco? We need to know about repair tools and how you use it. Oh, repair tools? Oh my gosh. Boy, I can tell you all day long about repair tools. I had a question from a subscriber about how to properly ground your scope, which I need to probably review for any new viewers here, but I'm going to fire this amp up real quick and so I can check the DC offset. So hold on to your ears, guys, in case something goes drastically wrong. I don't suspect it will, but hold on to those ears. Just let you know, I'm warning you now. Whew. It didn't explode, guys. Oh, but I got one fan that's not working. Oh my gosh. Got one fan out. All right. Anyway, I'll take care of that fan later. Let me check the DC offset. Oh. All right, guys. So, I know I'm going to try not to get too sidetracked. On these Uni-T meters, I don't know if you guys remember when I first got this, but I was pretty proud of myself. I got a meter that I can display on the screen there for you. But on these Uni-T meters, the rotary dial here's got two little plastic pins that rotate the contact switch. Those two pins will break on that. So they broke and this thing would just spin, and I repaired that, but while it was broke, it kind of distorted the copper terminals on it, so I kind of have a bad time getting to the right setting of the meter. So I just thought I'd let you guys know on these Uni-T, the UT61E, and probably all the rest like that, if you are good with repairing things, I would disassemble it, and what I did is I took my soldering iron and I melted the terminals into the rotary dial, because they're two pieces. I don't know why, but they are. So what I did is I got a new one. No batteries in it yet, because I want to secure that rotary dial before I start using this one. This one here will show temperature. So this one is the UT161D that I got direct from Uni-T. So my little sidetrack there for you guys. Let's check the DC offset. Hey, not too bad. 0.018. 0.017. Probably could get that a little lower. How about 0.001? Hey, that works for me. All right, 0.001 on the DC offset. This thing, besides some fan repair, will be good to go. These amps, what I like about these, they will let you know when there's a problem. It'll go into protect. It'll let you know. So I have no doubt in my mind that if I give it an input signal, it'll modulate like it should and have an output. So on these boards, now that it's powered up, just let you guys know, don't touch the rectifiers. How many volts? Let's see. What is the rail voltage on these MD12Ks? Let's see what you'd get your fingers in between here. Ah, yeah. 182 volts. That was pretty close. What did I say? 178? So 182 volts is what you're going to have on the rail voltage. So again, Don't be putting your fingers in the rails when you first shut it down, because it will take some time to discharge those rails. I'm a huge I'm really big on safety. So again, I'm a former electrician, so electricity, you have to respect it. So even right now, now that it's off, we're still at 163 volts. So if you're to put your fingers across those rectifiers, you probably are going to have a personal 4th of July going on. Let's see here. We need to know about repair tools and how you can use it. All right. Repair tools. Well, that's kind of a general thing. I mean, my camera doesn't quite show everything that I have over here. But is there a specific tool that you're looking for information on? You installed the amp dock replacement boards that you got from Jimmy. Oh, yes. Perry has a section of the PPI boards, PPI folder. Yeah, and I saw that too. When I was going through Perry's stuff for this morning's live stream, I thought I saw that, or it might have been on my paid version. Good to know. I was looking at those to get a new meter. Yes, Damon, if you do, take it apart and you will see what I'm talking about. The black rotary is a 2-piece on a white rotary part that's got the copper fingers. And you'll see the 2 plastic pins that I'm talking about. They'll shear right off. I usually only have to touch one, not even create a short, but just touching one will shock the heck out of you. Yes, Jesse, yes. Yeah, you don't have to be across the rail. You just have to touch that rail and you'll have a bad day. So on these amps that run these crazy high rail voltages, keep your fingers free and clear of the rectifiers and the output transistors. So your voltage just doesn't end at the capacitors. That rail voltage is at the transistors also. So that board's good. Let the glue, oh yeah, it's already starting to set up nice. Traces are soldered, inductors are glued in place. Inductor via is repaired with copper braid. 3 sections of it folded on both sides of the board. And DC offset is set at 0.00, what I say, 18. So I think the customer will be very happy with the results of this once I forgot I do have a bad fan. So once I repair his fans, and get it put back together. Otherwise, that's the board for today. So it took about an hour for me to go over this with you guys and do the repair on it and kind of give you my input on the pros and cons of these boards. Do you repair tube amps as well? Yes, I have done. I do believe I have some videos on that as well. I have done a few Butler tube amplifiers. My previous business was in the restoration of vacuum tube testers. So I am familiar with vacuum tubes and the tube testers. I've repaired and rebuilt a lot of Hickox, a lot of the military, the TV style tube testers, some Jacksons. I've done them all. So I decided to change my business to the solid state instead of vacuum tube. There's more demand for the solid state stuff than it is for the vacuum tube stuff. The fans are controlled by a thermistor or the PIC via a thermistor. This particular board is, well, all right, okay. So this is controlled by the PIC, the MCU. this particular board is. It does have a thermistor for a thermal shutdown, but they are not thermostatically controlled for speed, which again, I have brought up before in the past. If they could program like a 50% duty cycle in the MCU based on temperature, they could ramp the fans up and down based on temperature, and that would really help extend the lifespan of these fans. I replace a lot of fans. So it's probably going to read in the mega ohms on the resistance for the fan. Yeah, 0.42. See, that's 440 ohms, 440K. So that is definitely bad. But yeah, I do replace a lot of fans. Some of their amplifiers have that 50% duty cycle built into the MCU. At one point, I thought that I had a bad MCU because the fans would slow down. But the guys at Taramps said no, that's how that was designed. And this fan failed because it feels like the bearing, something's in there. It's made it real stiff, and then what happens is it heats up, and then if you're to tear these apart, there's a little board on here, and there's 3 sensors on it, and those sensors burn up. So let's see here. We need to know about what tools we need and how to use it for beginners. Yes. Yeah, technical specialist. And you know, I've brought that up before. I do believe with Taramps about, you know, programming that in would save a ton in fans. Just to kind of give you an idea. That here is about that's probably last month's, probably a month and a half of fan replacements right there. So that's how many of those go bad. Yeah, lots of fans. Let's see here. So the equipment for beginners. Well, soldering iron. You don't have to have a desoldering tool or a desoldering gun, but I do highly recommend a desoldering gun. These are somewhat inexpensive, but it'll get you a long ways in desoldering, soldering, removing parts. I mean, they're just a very versatile tool. Scope. Yeah, I can't state this enough. Some people say you don't need a scope to fix amps. Other people say it's a necessity to repair, you know, you have a scope to repair amps. In my opinion, you really should have a scope. So I got one right here. It's my scope right here. It's the Rigol DS1054Z. It's a versatile scope. Does everything I need it to do, everything I need to see. Works perfect for Class A, B, Class D amplifiers. There's nothing that scope can do that I need it to do. And you can't see, but further down the line, I mean, I have a Tektronix scope with my curve tracer, my DIY curve tracer. I have a signal generator right here It's a Heathkit, the IG1272 signal generator. I love that thing. I mean, I'm old school. Love that thing. I can vary the output voltage. I have full control over the frequencies, attenuation, multipliers. It's just a great all-around signal generator. I mean, sure, you have newer generators, today's technologies. I do have one sitting right off camera over here. That's an electronic digital one. But some inputs on amplifiers won't work with that type of signal generator. I have found that my Heathkit will work on every amplifier so far I've had on the bench for repair. 6 years, Central Time for a live stream. 7 o'clock Central. How many hours is that difference is that? It's 4:13 right now, so. But otherwise, equipment, simple, soldering iron. As long as you can remove and solder parts in place, as long as you have a signal generator, because you need to be able to put a signal in. A scope is highly, highly, highly preferred. You can get lost if you don't have a scope. And a multimeter, Uni-T multimeter. They're cheap. I got my new one, my 161D. I think I got it for like $75 off AliExpress direct from Uni-T. So 5. Oh yeah, you bet. Because I'm about ready to finish this up, Damon. If you do a live stream, I'll be right on there. See here. Yeah, and like Technical Specialist says, you can get cheap scopes. I just spoke with someone this morning about a scope. Or was it yesterday? I can't remember. But I said, they have these little digital ones that you can get. As long as it has the right voltage range, it would work perfect. Oh, and another thing, you need a power supply. That would be the last biggest thing, is a power supply. So, can I show you guys what I do? Yeah, I can show you. Hold on, guys. Let me show you. Alligator clips. All right, so I have alligator clips that go down to a power supply. And this, little dusty, that is what I use. This right here will power up 99% of every amplifier I repair. I'm trying to think of an amp that it won't start. I just can't think of one right now. So this is a 10 amp 12 volt power supply, switch mode power supply. That's what I use, and it's connected to my 2 alligator clips, and then I of course have my remote alligator clip that is just tied onto the 12 volt side. So this little alligator clip here is my remote, which is tied directly to the 12 volt down at the power supply. I have a 2 amp, but it's actually mounted down below. I have a 2 amp power supply that's on a foot switch for the smaller amps, where I can just hook up my positive, negative, and remote. And then I can just control the remote off the foot switch. But this time of year, I get a lot more bigger amps in than I do smaller amps. So that's what I would say gets you going for equipment. Last thing was just that power supply. And then of course you have your odds and ends. You have your solder. I use Kester. It's a 6040. That's a 0.040 solder. Little. It's a Kester. I call it. I think it's called Kester 44. I use that. It's like $32 a spool. You have to have a good flux. Amtech flux. Thanks Louis Rossman for the Amtech flux. I do have a hot air station, the ST862D, a hot air station, and I have another hot air station. I have a couple hot air stations over here, but that's my newest one from Rossman Repair. Fantastic hot air station. And then of course I have my soldering iron, the FX8 88D Echo soldering iron. So that's your basic tools for you. Let's see here. Type 8 amps won't build rail voltage fast enough to responsibility for the outputs to come on and cannot do it not having full rail voltage. Won't build rail voltage fast enough on small supplies before the outputs try to come on and cannot due to not having full rail. Pulsing doesn't work on them. The type 8s. I'd have to see what drive board that is. A type 8? I don't know, because even like the big pit bull, I can fire up a pit bull. I can fire up the crossfire, the 16K, 17K crossfires with this. I can, I don't know of an amp that I have not been able to fire up. There was one amp that I couldn't fire up that I had to put on the load bench to start it. I can even fire up the big, the Taramps 30Ks with this 10 amp supply. I don't know. I'll have to look into that. I'll have to look on Perry's guide and see. I can't envision right now what the Type 8 drive is. So, but that's where we're at. Oh, Micromage, hey, thanks for coming in. But yeah, that's where I'm at on that. I got one dead fan on this I got to replace. Of course, we'll add it to the pile here. Got noisy fans, but that's pretty normal, typical. Fires up, starts up, no shorts. So inductors are glued down. Once the glue sets, they are going to be going nowhere. So that's an MD12K for you. Another burnt MD12K back together. And I shouldn't say modified, but worked on in a way that I feel makes it a little bit more stable. So I do thank you guys for watching. If you guys stick around, I think Damon is going to be shooting up a live stream here. So Damon's a great person. If you can catch him, we can jump over on his stream. And Cardy, he was in earlier. If he sees this, hey, hi to you two again. Cardy he's another great guy. I like talking to him. And Having Fun Repairs. He's another great guy that does some electronics repairs. And of course, we all can't forget my mate Vince. We all love him. Alrighty, guys. Well, I'm going to jump off. We got this MD12K done. So catch me live again soon, or a upload I will have before too long of the next amplifier repair. Again, keep your fingers out of the rails.